Okay, so we're going to review inverse functions, or what they are. So what are inverse functions? This is something that comes up from time to time. Remembering the properties are kind of handy. So these are one-to-one functions defined by, so first of all, you've got this notation here, f to the negative 1. This stands for an inverse. So it's not an exponent. It literally stands for an inverse. So this is one of the most confusing things with this. So I want you to look at how this is defined. Yx, this bar means such that xy belongs to f. So what does this actually mean? Well, what this means is that you basically are interchanging the inputs and the outputs. So if you had a function f and it had the point xy, then the inverse has the point yx. You can just flip all the points. So just to drive that point home, so let's say a function includes the points, these points that you see here. And let's say that we know that it's a one-to-one function, so it has an inverse. So then what points will the inverse have? So what I would say then is that f inverse has the points 3, 2, 4, 5, 2, negative 7, and 5, negative 1. So that is really, in a nutshell, what a inverse function is. Now, something that's very important is not all functions have an inverse, but a very easy way to determine if a function has an inverse is to use what's known as the horizontal line test. And the horizontal line test says that a function is one-to-one if every horizontal line intersects the graph of a function at most once. So basically, if you can determine that a function is one-to-one, then you know it has an inverse. And the horizontal line test is a very easy way to figure this out. So I could have this example here, are the following functions one-to-one? So like I said, it's a horizontal line, and notice, like in this example, it's not intersecting the graph more than once at any point. So this would be a one-to-one function, while this function here, I drew this horizontal line, it intersects twice, so this would not be one-to-one. And so only one-to-one functions have inverses. If they are not one-to-one, then they technically do not have an inverse. And in case you're wondering why that is, the reason is that if the function is not one-to-one, then when you find the inverse would violate the properties of being a function. So that's long story short, just a quick explanation of that. Okay, so we're still talking about inverses here. So how do you find the inverse of a function? So first you replace f of x with y, and then you interchange x and y. Then you solve for y, and then you replace y with f inverse x. So I want to just go through and find the inverse, just to kind of quickly remind you of how this works. So we replace, oops, let me change my pen color. We replace f of x with y. And then where we have the x's and y's, we interchange them, like you see here. And then we solve for y. So I just do whatever I have to do now to solve for y. So you can see I'm just kind of going through the steps here. So I'm going to write this now as y equals 1/2 x minus 1/2. So I break this into two parts. And then I just finish this off by writing out the inverse. Okay, now what about if I have a slightly more complicated function? What about something like f of x equals the square root of x? So this one actually has a little bit of an interesting twist to it. So if I were to go through and set this up, so I flip my x and my y. So to solve this, I square both sides. But there's actually something that is assumed about the domain of this function. What is the domain of the square root of x? The domain is x has to be greater than or equal to 0. And this matters then because you have to also apply this domain to our inverse. So our inverse is x squared, but I need to make sure that I include the domain restriction as part of the inverse function. Okay, and the other thing that I want to just kind of briefly go over is, so what relationship do inverses have with their original functions? So what I want to do is I want to graph the functions with their inverse. So I'm going to start with 2x plus 1. So this is just a line, right? This mx plus b form. So I've got the y-intercept of 1. And then I go up to and over 1, up to over 1, and then down to over 1. So I just marked a bunch of points just to help me draw a nice straight line. Okay, and now I want to graph this with its inverse, so I'll do it in pink here. So we just found this, right? So this was 1/2 x minus 1/2. So here's my minus 1/2, and then I'm going to go up 1 and over 2. And so let's see, that should be, you're going to have to kind of be careful with the points. Up 1 over 2, down 1 over, okay. So I think this will help me illustrate my point. Okay, so I was very particular with how I drew my line because this is going to help me to make a point about this now. So the thing about inverses, I'm gonna emphasize this in both graphs. The thing with inverses is that their graphs are really just a reflection over this line right here. This line that you see right here is y equals x, and all inverses, when a function has an inverse, it's really just a reflection over this. So if I were to take the green line and then reflect each part over this like yellow orangish line, you can see how I would get the pink line, right? And that's just a natural property of inverses. So if I do that again with the square root of x, okay, so with the square root of x, so let's see, I've got 0, 0, 1, 1, 1, 2, 3, 4. Okay, so here's a couple points for the square root of x. Now remember, my inverse was x squared, but my x's have to be greater than or equal to 0. So in that case, I have 0, 0, 1, 1, 2, 1, 2, 3, 4. So if I go ahead and graph that. So once again, you'll notice, right, that I am reflecting over this line y equals x. So that's just like a property of these. So from the graph, we can see that the inverses are of functions are just a reflection over that y equals x. That was kind of the point I wanted to make. So that's just kind of a good thing to note about inverses. And then the last thing that I want to mention, which we've already been using, don't forget that the domain of f is the range of the inverse, and then the range of f is the domain of the inverse. So this makes sense, right? If you're just flipping your x's and y's, then the domains and ranges will flip as well. And so yeah, so that was just a really quick review of how inverses work. So I'm going to leave it there, and I'll see you guys in the next video.